So I hope you can see my screen for the presentation. But thank you very much for the invitation. And my name is Fabian Muff, and I present you today the M2AR modeling platform and the augmented reality workflow modeling language that helps us creating augmented reality application. I'm from the University of Fribourg, as well as Professor Hans-Georg Phil, and also Felix, who is in the audience today. So thanks for joining. And first, let's have a brief look at the program. So first, of course, I will tell you something about the foundations and the motivation why we are doing that. And we will have then a look at the creation of augmented reality applications. And I will introduce you then to the new augmented reality workflow modeling language that we developed in the last few years. And on top of that new language, we developed also M2AR, that's a new modeling platform. And I will also introduce you to the new modeling platform. And I will show you then some use cases and how we can actually model augmented reality workflow applications or just augmented reality applications in general. And I will demonstrate you the new platform and the language. If you have any questions during the presentation, please feel free to interrupt me so we can discuss also during the presentation if you have any specific questions, or otherwise we can also discuss it at the end of the demonstration. Let's start with the foundation. First, it is important to mention that it's not just about the creation of extended reality applications, but it's a combination of modeling and extended reality. If we talk about modeling, in our case, we talk about conceptual modeling, and in context of this presentation about model-driven engineering. So we use models to generate then extended reality applications. If you're talking of extended reality, we have the three terms: virtual reality, augmented reality, and mixed reality. And the new modeling language we are introducing is more about augmented reality, but I will just talk a bit on the next slide about these different technologies. So I assume you are all very familiar with modeling, conceptual modeling, and model-driven engineering. That's why we just step over this topic, and I will introduce you maybe to the less commonly known topic of extended reality. So if you look at the spectrum between the real environment and the virtual environment, we can have here different technologies on this spectrum. We have on the one hand side virtual reality, so that's really on the right side, near the virtual environment. And virtual reality is a technology where you are totally immersed inside the virtual environment. It means most of the time you wear like a head-mounted display, like for example Apple Vision Pro or Meta Quest, and you cannot see the real world that is around you. So you only see a virtual world. Everything you see is digital content, a virtual environment, and you can interact with that virtual environment in different approaches. Like for example here in this image, you just have a very small modeling environment, and you could create models in the virtual environment in virtual reality. Then we have augmented reality. That's a bit more on the side of the real environment. And in augmented reality, it's about adding digital content to the real environment. So most of the time you also wear a head-mounted display, but it's also possible to do that with a tablet, as in the lower left example here. And what is different to virtual reality, in augmented reality, you always see the real environment. So you see the real world as it is. And on top of that, you can now show additional virtual content. So you can augment the real environment with virtual information. And we will see examples of that later. And then we have the common term mixed reality, and that's basically a mix between augmented reality and virtual reality. So you have most of the time a head-mounted display where you don't see the real environment directly, so you can have virtual reality with these devices, but you can have then like a see-through mode where you see on a display the real environment, so you can also have like augmented reality experiences. And all of that can then be summarized as extended reality. So that's why we say it's modeling for extended reality. But in our case, in our research, most of the time we are considering augmented reality. And the reason for that is that most of the concepts you need in augmented reality, they are also needed in virtual reality. And of course, you have additional concepts in augmented reality since you have to consider the whole real environment, but everything that is necessary in augmented reality can also be applied to virtual reality. And that's why we most of the time just look at augmented reality and we just talk of augmented reality, but most of the concepts, they are also applicable for virtual reality. If you think now about modeling, conceptual modeling in extended reality or augmented reality, maybe it's hard to think of use cases, what that can mean. We have here some examples, like in the top example, for example, it's about business processes, about process guiding, where you have in the background a process model and you could annotate that with virtual information. And in the real world, you could now be guided through this process. Or in the lower example, you could just visualize enterprise architecture models and have here different layers, and maybe it's easier to understand these different models or these different layers if you can see them actually in 3 dimensions instead of just a 2D screen. Or there's another example here where you could use models in the background. If you imagine a server center and you have a problem with your server, then you could use background information of models and sensor information of the real world, and you could combine these 2 things, and the application could give you then guidance on what you should actually do on your server to fix a given problem. Just as some examples. And let's come to the creation of such applications. It's nice to have such applications, but the problem is it's quite hard. If we are talking of AR applications, so we do not really consider like games or just marketing apps. In our case or in our research, it's most of the time about knowledge that is document-based, like processes, manuals, and so on. And we want to bring that back to reality. And for that, we use XR applications. So if, for example, if you have a repair process or a maintenance process of an industrial machine, then you have huge manuals on how to maintain a machine. We could use now this knowledge from these thick manuals and bring them back to reality and show the maintenance worker with XR applications where he has to do what he has to unscrew, which button he has to push, and so on. And that is possible already today, so we can create such applications. The problem is only that it's quite complex to do such applications. So today it requires deep know-how and very advanced programming skills to create large augmented reality applications. For example, we can use the Unity framework, or we can use Apple's ARKit or Google AR Core, and so on. So there are many approaches, but for most of them, you really need deep programming knowledge, and you also need knowledge about domain to create such applications. And there are some proposals in research and also some products already which try to use model-driven engineering and conceptual modeling to facilitate that creation of augmented reality applications. Like, for example, there are approaches like describing AR scenes with platform-independent formats, or the example we saw before, a BPMN extension for creating processes that can then be shown in augmented reality. Or of course, there are also some low-code and no-code tools which allow us to create very simple AR applications, but they are not really meant for complex workflows or processes. And the main problem of all of these approaches, which already exist, is that they are for very specific problems. So they are not like general approaches that can be used for a variety of different use cases, but most of the time they are very specific for one area. And we thought then about the solution for that. And we thought, well, we can use conceptual modeling for multiple application scenarios. So not just for one specific use case, but for generic use cases. And we wanted to create an augmented reality workflow modeling language that is capable of covering all of these different application scenarios, and which can then be used, or the models created with that language can then be used to directly create these augmented reality applications. So we don't have this, we don't have this direct approach anymore. I just try to take the laser pointer. So we don't have this direct implementation anymore where we have the knowledge and we say we want to create an application exactly for this use case here for machine maintenance. But we say, well, we have here a modeling language which allows us to take whatever scenario we want and create models. And based on these models, we can then create automatically augmented reality applications, no matter what scenario we choose here at the beginning. And for defining this modeling language, we first had to look at the whole domain of augmented reality or of extended reality. And we had to find out what are the different concepts which are always there, because we had to consider that for a modeling language. We had to know what is actually always necessary for these augmented reality applications. And we have then here different concepts. The first concept we call detectable, and this is for the detection of real objects in the real environment. So we have to detect different areas, objects. We have to get the context out of the real world, because if we don't have that, we're basically blind. So we cannot do augmented reality if we don't know what is in our surrounding in the real world. That's why we have to detect things. Like here, for example, we would have to detect that there is actually a machine in the room, and based on that we can then do further stuff. Then we have the concept of augmentations. This is basically just virtual information added to the real world. In this example, that could be just virtual arrows, but this can be any 3D object, or it could be text labels, videos, images, or it could even be non-visual information like sound cues or whatever. Just digital information we want to add somehow to the real world. Then we have conditions, and conditions is a concept to react on certain states in the environment. So for example, if we are going near to something, or maybe after a given time, or if we touch something or whatever, maybe we want to react on that event or on that condition. And that's the concept of conditions. And the last concept we need here is state change. And that's a concept to define the visual representation of an augmentation at a given point in time. It means we can have augmentations, so what we defined before, the concept of augmentations, but there we do not define if these things are visible or if they are activated or at which position they are. There we just define that they are in our environment somehow. And with state changes, we can now define at a given point in time, we want to activate or we want to make visible a given augmentation, or we want to reposition it, to animate it, and so on. So with that, you can basically steer how these visualizations are, or augmentations are represented in the real world during our application. And so we derived first these concepts, and in the next step, we are then able to specify our modeling language. And we tried to separate a bit these different concerns. So we didn't want to put all of that just in one huge modeling language, but we divided it into different model types. And we have here in total 3 model types. So we have here the object space, then we have the state change, and we have the flow scenes. And this is the meta model specification of the whole modeling language. It's called the Augmented Reality Workflow Modeling Language. And with these model types, we can now create our models, which will then be run as augmented reality application. And the first model type, the object space, is basically just there to describe what is in the real world and what virtual information do we want to show in the real world. We don't specify when we want to do that. We don't specify how that should look exactly. We just say, well, we have things to detect. For example, we can say we want here images to detect, or we can say we want objects to be detected. That would then be detectables. And we can define augmentations, for example, images or 3D objects. And we just say, well, they are in our object space, and we define not how they should look or when they should be visualized, but we just say they are somehow needed in our environment. And then we have here the state change model type. And in state changes, we only have one class, it's called reference. And this is basically creating a reference to an instance of an augmentation. That means we say here, if we activate that state change model, if we create one, then we can have references. And there we say, well, an augmentation that is referenced should be visualized in a given way when this state change model is activated. And we'll see an example just in a minute. But basically here we define how these augmentations shall look like during runtime. And then we have the flow scene. And in the flow scene, we define the logic of the whole application. So we define the workflow, what shall happen at which point in our augmented reality application. And first, we have here to define an object space. So we have to create a reference to an object space model, and that defines then all the things you can use in our augmented reality application, because we can only have here one object space, and in there we define all the things you can detect and all the things that shall be augmented. So we can just use what is then referenced here in this model. Then we have here the concept of conditions, where we say we have different conditions. For example, we could have here detection condition, where we say we want to detect an image. So we have to here a detectable reference, where I say we want to have exactly this detection of this detectable. Or we could also have, for example, here a click trigger, where we say if we click on an augmentation, or we could have a timer, or we could use sensor data based here on observers and so on. So there are different possibilities to create conditions. Then we have state changes, and they always follow on a condition. So they are triggered by a condition. And here we actually reference then a state change model. So we have here very modular the different state changes, and in the logic of the flow scene, we just say which models shall be activated at the given point in time. And let's have a look at an example. Maybe it's then a bit easier to understand. So we first specified that whole language, and we implemented it then on a 2D modeling or meta modeling environment. It's called ADOXX. That's this modeling tool here. And we implemented these 3 model types on that platform. And we are then able to model instances or models with that platform. And you can see here an example of an IKEA furniture assembly process. So you all know like IKEA furnitures, and most of the time they have like manuals, and we just took like one of these manuals and tried to assemble step by step, or to create here the process how that should look like in the real world. And first we have here the object space, so that would correspond to this model type, and we have here just 10 detectables. We say, well, these are instances of specific color markers which can be detected by an augmented reality application, and we have here different augmentations. So we would have here, for example, the 4 legs of the IKEA bedside table, and you would have the 2 plates. So one is the top plate and one is the middle plate. And we don't specify here how that should look like in the real world. We just say in our application, somehow we need 10 detectables, and we need here these 6 augmentations. Then we can create here our state changes. And in the state changes, we create now references to the different augmentations. For example, here in the state change 0, we would just say we want to visualize this middle plate, and we have here a list of the different properties like rotation, position, visibility, and so on. And we have to specify then where that should be positioned in the real world. The same here for the next state change. I would say, well, now we want to visualize the first leg now in the real environment. And at the end, we can then create the whole logic in the flow scene. Here we first define our object space. That's here this square, and everything we define is inside this object space. So the object space is creating here a reference to that whole model. That means we can only reference things which are defined in that object space. So we cannot now just have a Lego brick inside of that model, because we just defined here these different augmentations and detectables, so we can only use this set of instances in our model. And we can define here first then the origin, because every augmented reality application needs somehow an anchor point, an origin. So we have here just a first reference to detectable. I marked that here visually. Of course, this is then made with the attributes during the modeling process, but we cannot see here the attributes. That's why I created here these red references. So this is the detectable that is used as world origin. And we have then here different conditions, which always say they check if a reference here or a detectable is detected. So if we are now in our AR application and we would see this marker, this would trigger the next step, and that is a state change. And this state change has a reference to this init middle plate state change, and that would show us then the first middle plate in the AR application. And like that, we can now create the whole process of our AR application step by step. So we can create the whole workflow, how that should look like in the real world based on different triggers like detectable triggers or click triggers or timers and so on. And if you think now about that whole process, in that furniture assembly use case, we would say then, well, we have now this document-based knowledge, that would be that IKEA assembly manual, and we could take that and we could model it with our new modeling language, would create an augmented reality workflow model, and at the end, we can now export all of these models together, and we created an AR application that can take as input these models. So not just for the IKEA assembly process, but whatever models we create with our augmented reality workflow modeling language. And if we import them and we start the application, it loads in the background our generated AR application and executes it based on these models we created. And with this approach, or this first approach, we were able to reduce that generation or that creation of AR applications quite a bit, but it's still very complex. So we don't need programming skills anymore, but there is a problem with the third dimension. So if you imagine here this state change, that would be a bit more complex state change where you would have all four legs and the middle plate of the IKEA furniture piece. And you would want to define how this looks in the real world. And for that, you have to define here the different positions and the rotation of all these different objects. And in a 2D modeling tool, it's basically impossible because you cannot imagine based on quaternion rotations and a 3D coordinate system or 3D coordinates, how that would look all together. And what you or we basically wanted is something like that. So we don't want to model it in a 2D environment, but we would want to model it in a 3D environment so that we would see directly how these state changes would look like in the real world. And for that, we needed a new 3D enhanced modeling platform. And that's what we did in the next step on the basis of that modeling language. But that's the M2AR modeling platform. That's a web application. And this is just the basic architecture of the whole application. So we have in the background a common data structure. That's here this global shared data structure. That's how we call it. And this defines basically the structure of these different modeling languages. So in the case of the augmented reality workflow modeling language, we need 3 different model types or 3 different scene types. That's how it's called in the new platform. But based on that structure, we could basically create many different modeling languages. So it's not just for these 3 languages, but we can create many other modeling languages with that approach. Then, of course, we have a database that is based on this structure. And we have an API server that allows us to access this database, which is based on that structure. And then on top, we have a web server with 2 web applications. First, with the modeling client that allows us to create augmented reality workflow models on the basis of a 3D modeling client. So we use here the Free.js library. That's a 3D web library that allows us to model in a 3D environment. And we have here the AR engine. And the AR engine is at the moment a separate application, but it's built with the same technology stack as the modeling client. So in a later stage, we would want to combine all of that into one application. but for now it's just an independent web application where you can say, we take that application on an AR device and we import the models we created on the instance modeling client, and you can then run in this AR engine or AR applications. So on the basis of the language and the new modeling platform, we had then, of course, to adapt the notation of the new modeling language. So this is basically the notation of the modeling language in the ADOXX modeling tool. And it's all 2D based. So you can see these are all like flat images. And for the state changes here, for example, we cannot see how these different objects are aligned. And in the new modeling platform, we have now a 3D environment. That means you can also use 3D visual representations of these different classes and relations between our objects. And this is the new notation that we defined in the new platform. And what is interesting here to see is that all basic representations are already three-dimensional, but for example, for the object space and the flow scene, it's not mandatory to have a 3D modeling client. So that we could also do in 2 dimensions, because there we just define what is needed in the real world or in the environment. And in the flow scene, we just define basically the application workflow. So we can also just have a look at the whole client in 2 dimensions, but especially for the state change definition, it's then important to have 3-dimensional view, so we can switch then in the modeling client to 3-dimensional view, and we can actually model with 3D objects instead of just 2D flat images. But we will see some examples of that. So this is then just, these are some screenshots of the modeling client for this IKEA furniture assembly workflow we discussed before. And what's interesting here is you can see here for the state change definition, we can now actually model the different augmentations. So for example, here we would just say in the object space, we have these different 3D objects. These are the CAD models from our real IKEA furniture piece. And we just say we have all these things inside our object space. And in the state change, we can now say how they should be visualized in the real world. And we will see a comparison between the different models in some minutes. But let's look at another use case, and I will just start with how that looks then in the AR application. So the use case that would be that we just pile up different color bricks. Most of us know them as Lego bricks or Duplo bricks. And the use case is just to put them on top of each other. So first we want to visualize the green one, then the blue cube, and then the red cube. And if you want to model that, we can do that with our new modeling language. First, if you look at the left side, we have the 2D modeling client of ADOXX. So we would have here the flow scene and the object space in 2D. And we also have the state change definition. So this is just an example of the first state change and the last state change. And you can see here, you don't really see how that looks like in the real world. So you cannot imagine how you should set these values here for position or for rotation between these different objects so that it looks like really piling on top of each other, these Lego cubes in the real world. And that's why we needed our new M2AR modeling platform, where we can actually then say, well, we want here the 3D object. That's a reference to this augmentation, and we want to place it in 3-dimensional space. if you just have one object, we don't really see the difference. But if you have now more objects, references to multiple augmentations, we can actually set them into relation to each other. And like this, we can really imagine how that should look like, how that will look like during the AR application execution. Let's look at the small example. So you saw here we can switch to the 3D mode, and we had then actually a 3D environment, and we can just move around then the 3D objects. So we will see a longer demonstration of that later in the presentation. But what I wanted to show you here is just that we can switch to 3D, that we can then actually model how that looks like in the real world. And we don't have to set here attribute values of rotations or positions, but you can just drag the objects around and see directly how that looks like later on. And if you look again at the execution and these different models, we would see here that we first detect here the origin, so that is the origin marker. Then we step to the first state change. Then we have the condition of 5 seconds, and we show the second state change. And then we have another condition of 3 seconds, and then we reference here the first state change, which would be visualized then like that. Then, of course, we already saw that we can have different use cases. I will just show you some examples of different use cases. That's the use case we already saw of the IKEA assembly process, where we have here the flow scene, which is just, in this case, a linear flow or a linear process. And we define here based on the different detectables, which are referenced in the object space. And we trigger here different state changes, which are modeled as separate state change models. And in these state changes, we can then say how that should look like in the real world. So for example, this state change here would then correspond to this image here in the real world or during the execution of the application. This is another use case, and here it's not a linear flow, but it's more like a guided tour where you have different possibilities. So the use case would be that you are, in this case, in a research center at the university, and you have different research groups. And you would say, if you are at the office or at the place where this research group works, you want to see virtual information about this research group. In this very basic example, you would just want to show them a virtual cube with a description of this research group and what they are doing. And in the flow scene, we would just have here different conditions, and we would have many different state changes. So for each of these research groups, we would need a separate state change where we specify which augmentation we want to show if we see a marker of that group. So here it's not very good visible, but we would have here for each research group a color marker that is used as a detectable, and we would have an augmentation for each research group, which shows then just on a cube a textual description of that research group. And here we have the references to these different augmentations, and in the state changes, we reference all of these different state change models, which are then shown if we detect one of these markers. So for example, if I come here to the office of the digits group, a digitalization and information systems group, then we would have here a marker. And as soon as I detect this marker with my augmented reality device, I would see here the virtual information or the virtual cube with the description of that research group. Or then we have here a use case with a machine. This is just a simulated use case since we don't have big industrial machines here at the university. So this is just an image how that would look like. But this very basic example, we would just check here first if the machine is turned on or if it is off. We could check that with observers, and if the machine is off, we would just show the user here that he should push the button. So we have created here state changes. First, we only showed the first arrow that is defined here as augmentation. Then we have a second augmentation which says push here. After additional 3 seconds, we just show here the arrow and the push here. And then we would go to the next observer. And then we would have here a use case where the user have to do some tasks at the machine. And as soon as the task is finished, we would again show the user here where he has to push to turn off the machine. Just as a very basic use case. So let's have a look now a bit at the code base and how this is set up. We developed all of that in different small projects, and we manage all of that in Git repositories. And we have just one basic Git repository where we have our whole documentation. So we have here for the user the whole installation procedure, how the structure of the whole application or the whole platform is defined. So here we have an architecture overview that corresponds here to the image I showed you before, the global data structure, and then the API server, and the Postgres database, and of course the modeling client. And the whole installation instructions, we will just see a bit more of that. I will not show you how to install the whole platform in this video. At the moment, the whole application is not yet publicly available. I hope until the end of the summer it will be publicly available, so you can also try to install and to run it by yourself, but for the moment it's still closed, but hopefully it will be soon publicly available. Now here we see the database. So we have here the Postgres database, which holds all the information on that global data structure. It stores, of course, all the information about the structure of the modeling languages, and of course then also of the models we create with the modeling platform on the basis of these languages. And we can install the whole database either as a Docker image that runs in a container, or we can also have a local installation of a Postgres database and just run it on your computer on your server as you prefer. Then, of course, we have a repository for the whole modeling client. That's a Node.js application that is using Aurelia 2 and is based on the Free.js web framework. It allows us to do all that 3D stuff we saw in the video before. And then, of course, we have a repository for the whole API. It's called here the M2AR server, where we define all the routes and all the procedures for accessing the database. We added there some user management, some consistency checks, and so on, so that we have really a full-fledged platform that allows us to model consistent or valid models. Then we have here the code base. We will not talk too much about that, just to show you that we have here these different folders of the different repositories. And So for each of these components, we have basically a different repository that can be managed separately. So if we change something at one end, it doesn't has an influence on all the other parts. So since it's a node application, we could just then start the whole application with some basic commands, but we will not go into too much details here. Let's have a look how that looks like when it's started up. So we have here then the whole API. For that we have a web interface where we can check all the different API endpoints. We used here the Swagger UI, and you can see there are many endpoints. First, for the whole structure of the different modeling languages, and then of course also for the different model instances. So if you actually are creating models and you want to store them to the database or retrieve them from the database, and we have here separate API endpoints for all of them. Here in this example, it's just an example how it looks like if you want to get, for example, here all the different modeling languages we have stored in the database. We could use here this REST endpoint for getting all the different scene types. Then we also started here the front-end client, and this is how the front-end client, the modeling client, looks like. So that's just a one-page web application where we see here on the left side all the different modeling languages. And of course, we have then here the basic features of other modeling languages, like storing models and importing models or modeling languages, and so on. So really like the overall necessary tools. Let's look then also how actually modeling works. So that's probably the most important or the most interesting part. We'll see here again the modeling use case for the color bricks. So first, we just have to create an object space. We say we create here a new object space. It's called color brick object space, and we also create a new model for the flow scene. It's called the color brick flow scene. And you can see we can switch now here tabs, and we have always just the different modeling elements for this specific scene types available. So for the object space, we just have the detectable and augmentation. Here, if you want to define now a detectable, we would have to choose here then the marker if it's an image we want to detect, and we say here that's an origin, so we have set it to true, so that we later can use now this augmentation as real-world origin. We also have to create then here 3 different augmentations for each color brick. So you have the red, the blue, and the green color brick. And for that, we add these 3 augmentations, can give them names. Not really necessary to have the names, but to recognize later on, it's quite useful. We can set then here the type. In this case, we just have 3D objects, and we can now import the 3D object. It's in the form of a GLTF, and the visualization is then automatically replaced by the actual 3D object we just imported. That means we can use CID models in the form of GLTFs, and we can just reuse them in our modeling environment. Now here in this example, we just see here, we took the wrong object or just another one. This is a 3x2 Lego cube, but we just want here a 2x2 Lego cube with the size of 30 centimeters. So we have to change here again the visual representation, and then we have the actual 2x2 Lego cube we want to use in our application. Then for the last augmentation, we just import the blue cube, and then basically we have everything defined that we need here in our object space. And we don't define here what will be done with these things. That we will later do in the state changes. But in the next step, we define here the flow scene. In the flow scene, we just define the different steps of our augmented reality application. So we need here first an object space that contains an origin and an exit, and we just connect it to a start object and to an end object. Just since it's a flow or it's a workflow application, we always need a start and an end. And we can now place here different conditions. For that, we have the condition class. And we saw in the example that we need here 4 conditions. And we can also give it here a name, and we can define here the type of the condition. In this example, we just use the timer condition. So we always have the condition type timer, and we set here the time or the delay we want to wait before the condition is triggered. But we could also use here detection conditions or click conditions and so on. Just in this very simple use case, we just set here fixed timers so that we don't have to detect any more detectables. Then we also need some state changes. In this case, we need 3 of them, first for the first cube, then for the second cube, then for all 3 cubes. And these are just the placeholders, and later we will connect them with the actual state change model. We will see that in a minute. First, we have to create here a reference to the object space, the color brick object space, that defines that we can only use things we defined in the object space for this use case. So we can always only have one object space, and here we define the origin that is part of this object space, which defines the world origin of our AR application. And we then have to connect all of these elements to a single workflow so that later on the AR application knows based on that workflow what step should be done next. So in this step, we have now to connect the different state changes. So we did not create them yet. So we first have to create these 3 different state change models. So we have here state change 1, state change 2, and state change 3. And in these state changes, we then have to define references to augmentations of our object space. And there we define then how that should look like in the real world. So in the state change, we define the positions and the orientation and so on of these different augmentations. And first, in the flow scene, we just reference from a state change class instance to a model. So we do that for all 3 state changes in the flow scene. And we can then go to the state change model itself, and there we can use the reference class to define which augmentations should be visualized how. So first, just say we have here the green colored cube. We say we want to set the position, and we say we want to make it visible. And we don't have to set then here the properties for the position, but we just choose which augmentation we want to reference. And we can then switch to the 3D mode, and we can actually place now this 3D object and define how we want to visualize it in the real world. So we don't need this list anymore. We saw in the 2D approach, but we can just drag the objects around and define how they should be in relation to each other. Of course, we also have to do that then for the second state change and for the third state change. At the moment, we don't have the possibility to copy paste different state changes. So for example, if you want to reuse another state change, it would be nice to just copy it and switch or change some attributes. But at the moment, this is not possible. So we just have to model it again. So first we add again the green cube, and then we do create the reference for the blue cube and place it on top. In this case, it's on top. And then we also have to do that for the last state change, where we have then to create all three of them. So you can see, you can really move here around in the 3D environment, have a look at the different angles and how that looks like in the real world. And in the third state change, of course, we have to do that again for all three cubes. If you have done that, we can just export all of these elements. So I will not show you now here again for the third state change how that works. But at the end, if you have all three state changes defined, we can just export the open models. And we can use this file now to import it to the AR engine. And the AR engine is just a separate web application. And here we could just import it and start then the AR application. So that would be the example of the models we just saw before. So we would first detect here the origin, and then we would trigger the first state change that shows only the green cube. I modified here a bit the time sequence so that it doesn't go too fast. So it's a bit longer here for the triggers. Then in the next step, we would add here the second cube just on top of the first one. And in the last step, we would then add also the red Lego cube at the top of all the others. That's here the case. And of course, we cannot do that only for the Lego cubes, but we can do that for all the different models created with the new modeling platform. So you can just export them and import them in the AR engine, and we can run them as augmented reality application. So that was it from the fixed presentation part. This is just some literature from the last few years, which have to do with this whole project. And of course, if you have any questions, I'm happy to discuss that. Also, if you watch the video online at a later stage, you have any questions, please feel free. Just write us an email or per LinkedIn or whatever you prefer, and we can happily discuss then your questions. But now I would like to ask to the audience if you have any questions or if you want me to show some additional things on the platform, or if you should have a look at an additional example.